Hello everyone, welcome to our statistics channel, Quality Statistics. In the previous videos we discussed line chart, pie chart, bar chart and so on. In today's video we will discuss ratio chart. This is a special type of chart. The ratio chart, a variant of the line diagram, is the semi-logarithmic chart or ratio chart. That means ratio chart has another name, semi-logarithmic chart. Where the vertical scale is logarithmic, there are two axes whenever we measure something with respect to two-dimensional figure. Vertical scale is logarithmic, but the horizontal scale is of the usual arithmetic type. That is, there are two types of scales will be measured here. In the arithmetic scale, also called natural scale, and distance between 2 points is proportional to the difference between the corresponding values, whereas in the logarithmic scale, also called ratio scale, logarithmic scale has another name, ratio scale. The distance between 2 points is proportional to the difference between the logarithmic of the corresponding values. Logarithmic value will be considered when the data is in the form of power form, and in other words, equal distances represent equal differences in the arithmetic scale. Equal difference implies the existence, the generation of straight line in the figure, but equal relatives in the logarithmic scale. Now, obviously, if the variable under inquiry is increasing or decreasing at a constant ratio, that is, variable may increase, variable may decrease, constant ratio, then the ratio chart will be exactly straight line. Actually, the generation of straight line depends on the change in ratio pattern. Here the ratio pattern is constant, therefore that will be straight line. The ratio chart is obtained either by plotting the actual values of x and y on a special type of graph paper in which natural scale is used and horizontal direction, and the ratio scale, that is logarithmic scale, is used vertical direction. That is, along x axis one direction, along y axis another direction. By number 2, by plotting the value of x and log y on an ordinary graph paper in which the natural scale is used in both the horizontal and vertical directions. In graph paper is 2 dimension. In one dimension we measure natural scale, and in other dimension we measure logarithmic scale. To fit an exponential trend, equation like y equal to a b to the power t, that is, y is dependent where t is time and a, b are constants, we may use ratio chart where log y, taking log on both sides, log y equal to log a b to the power t, that is log into means log plus, log a plus log b to the power t, that is t log b, is the linear function in terms of logarithm. Why linear function? Because there is no power here. Graphically we can measure t along the horizontal axis, that is natural scale, and log y, which is dependent, along the vertical axis, that is ratio scale. There are some situations where we have to use both direct horizontal and vertical logarithmic scales. For example, to fit a trend data equation given by the power function of the form y equal to a t to the power b. In the previous form we discussed y equal to a into b to the power t, that is, t was the independent variable, log y was the dependent variable, and in this case we arrange this log y equal to log a plus b log t. That is, log t is independent, log y is dependent. In the previous structure, only t versus log y. In the present structure, log t versus log y. Here we have to measure log t along the horizontal axis and log y along the vertical axis. Now we discuss a problem with respect to this knowledge. This is a problem from the following table. Draw a ratio chart on a graph paper. Year is given here 1981, 82, 83 and order 87. And units sold also given 3, 9, 27, 81, 243, 729, 2187. Solution. Since the units of output sold are in GP, series there is a common ratio and common ratio between any two successive observations, the ratio is constant here and it will produce a straight line. This is clear. Our assumption was if the ratio constant, then this will produce straight line. Here ratio is constant, that is we will get a straight line figure. Along the x axis we use 81, 82, 83, 84, 85, 86, 87. Along y axis 1, 3, 9, 27, 81, 23, 79, 2187. Plotting these points we get this line. This is hand measurement, that is straight line, we get a straight line. It should be noted that the baseline does not represent 0 as is necessary in the natural scale. Also, equal distances in the vertical direction represent equal ratios of changes in, that is 3 to 9, 9 to 27 and etc. Here the logarithmic chart or ratio chart is complete. Now we will discuss what type of advantages and disadvantages we will face in ratio chart analysis. First, we will mention the advantages of ratio chart. Advantages, what will be the advantages? Number 1, a ratio chart is to be used when the diagram is to show the relative changes in the variable rather than the absolute magnitude of change. And number 2 advantage is that to compare the relative growth or decline of 2 or more series, we may draw the ratio chart for the series and compare the slopes of the charts. Another advantage is there, a ratio chart is also useful for representing a time series with widely defined values. In spite of these advantages, we face some disadvantages also, and the disadvantages are: number 1, absolute changes cannot be easily compared on a ratio chart. Number 2, 0 or negative values cannot be represented. Number 3, it requires a knowledge of logarithm. Without the help of logarithmic knowledge, this cannot be done. This is all about today. Please keep watching to our videos for further updates and new videos. Thank you all for watching this video.